Hi, everyone. It's such a pleasure to be here in Peru with you. And I think blockchain technology in particular is a very important technology for Peru. So as we all know, corruption is a tremendous problem here in this country. And it's really halting Peru's chance to grow and potentially Peru's chance to really take its place on the world stage. And so the question is, with corruption, how do you start to change things? Because you have to go really deep and change a whole lot when you've had corruption in a system and in a country for a long time. And so what I'm going to suggest in this talk is that we can start to use blockchain to fight corruption here in Peru and also around the world. And we'll get into why that is. So for those of you who are unfamiliar with the exact details of the Bitcoin blockchain, how many people have heard of Bitcoin? Okay, everybody in the room. This is the first block of the Bitcoin blockchain. And you can see that this block refers to an article in the Times of London from January of 2009 saying that the Chancellor is on the brink of the second bailout of banks. So every block on the Bitcoin blockchain can have some text, some metadata associated with the transactions. So you can go ahead and you see the transactions, but on the side, there's this reference to the Chancellor in England bailing out banks again. And Bitcoin actually came to life in 2009 in the wake of the financial crisis, the global financial crisis in 2008. And a lot of people became aware, some of them for the first time, of some of the deep corruption in finance in all of our world. So this is a problem that's a global problem, and the creator of Bitcoin, Satoshi Nakamoto, whoever he or she or they may have been, in the very first block on the Bitcoin blockchain, which they knew would last forever, they made this reference to bank bailouts and corruption, and it indicates that at least part of Satoshi Nakamoto's motivation is to create a new kind of monetary system that can be free from the corruption of our traditional systems. Now, the World Bank, to point out another issue with our global financial systems and challenges with corruption, we have a challenge of how do we document land in a fair way and in a way that will support those people living on land without good ownership records actually starting to enter the global economy. Because in today's world, only about 30% of our land is well documented on a global scale. And the rest of the land, the people living on that land, they can't prove in a court of law in their local jurisdictions that they own the land. That means that no one will lend them money based on the land as collateral, and so it really prevents them from improving their land. And it's a key problem for economic growth. And Hernando de Soto, who is a famous Peruvian economist, has been talking about blockchain for a long time, and actually last week gave a speech where he talked about the power and potential to use blockchain here in Peru to start securing land ownership. Because and we'll get into this in the presentation and why this is, but when you have a blockchain-based system, you have a permanent digital system of records. You can see every change that is made. You can see when it's made. And you can't go in and make changes that no one can see. And that kind of light on a system is very powerful for rooting out corruption. And actually today, we have systems of starting to put land records into blockchain databases in Africa with Bitland in Ghana. And so you've got surveyors going into communities in Ghana, working with the local communities to start to build out land registries using blockchain. And even, I'm going to talk about this at the very end of the presentation, but here in Peru right now, you have a startup initiative called the Blockchain Initiative in Peru that's actually working on starting to secure water rights in certain indigenous communities using blockchain. So that's our future. I also want to give a shout out to a very cool pilot program going on in Mexico, working on using blockchain to start fighting corruption, which is putting public procurement records and applications onto the blockchain. So when you have a public contract, a government contract, that's a key place where in more corrupt areas, the officials that get to choose a vendor for a contract will choose their friends or engage in other kinds of corruption. But if you start to put the records on blockchain, you can put the application of everyone who tries to get the government contract out into the public record for everyone to see. And you can make very clear why the winning bid is winning, not for reasons of corruption, but for reasons of being the best bid. And that's something everyone can then look at. So blockchain technology, it's really powerful for fighting corruption, I've been telling you, but you might have this question of, well, how does it work? So before we dive into how it works, I want to do some level setting and some stage setting. And I know it's right after lunch, but bear with me here. How many of you have sent an email today or in the past couple days? I should see every hand. And how many of you really understand the underlying mathematics, the ones and zeros of that message that is your email and how it traverses our global internet system using the DNS system, right? It's mathematics and computer science that gets your email from one server and one computer to another. So how many people feel like they have a really good grasp on that? I'm seeing fewer hands, but remember, you can all send emails. And so the level of understanding that we're going for here is that conceptual understanding. The ability to understand how blockchain works, kind of like how you can understand how email works without having to dive into DNS. And for those of you who are deeply mathematically inclined, I'm very happy on the breaks and at dinner to get into it with you. So if I'm going to give you blockchain technology in one sentence, this is it. Blockchain technology helps to solve the problem of permanence on the internet. So I don't know the last time any of you has tried to go find a website from 1994, but this is probably the message you're going to get. 404 file not found. The internet is littered with 404 file not found because as much information as is being created and shared on the internet, there's enormous amounts of information being lost forever because the internet is not permanent, right? And if you have a website hosted on a server and you stop paying your hosting fees for whatever reason, or you want that website gone, it gets erased. So the internet, remember, information is very, very easy to erase and to change on the ordinary internet. But with a blockchain-based system, you can go ahead and look at every single block. There's not a single block that can be erased. And so we can still see every detail of that first block of the Bitcoin blockchain. Let's talk a little bit about how that happens and why that happens. So with blockchain technology, instead of sharing information in one place, you have multiple copies of the information. So for those of you that have used Excel, your traditional internet is more like an ordinary Excel spreadsheet. And for Google Sheets, which is a new version of Excel that you can actually use and you can share the same Excel file among multiple people, that's moving more in the direction of blockchain. Now, instead of just one copy of the information, we actually can have many copies. But there's a problem with Google Sheets. And the problem with Google Sheets is that you can go ahead and delete the edit history. When you think about corruption, think about what it means, like, just on a very small scale. If I'm working on a class project with some friends and we're working on Google Sheets and I go ahead and I haven't contributed to the project, right before we turn it in, I delete the edit history. No one can see who contributed to the project when, right? That's the problem. When you can make deletions and no one knows who did the deleting, that opens up room for a whole lot of cheating. And so with blockchain technology, what we have is peer-to-peer distributed information. Instead of information being kept up at the front, every single person here in this room could have their own copy of all of the transactions. And you can look at your own copy and see if you're being told the truth or not. But there's a problem and there's a challenge. What's that challenge? Okay, so let's say you're following me so far, you kind of see, instead of having one Excel spreadsheet, we can each have a copy, we can each see all of the transactions. But what happens when there's a new transaction? So if you think about property records on blockchain, instead of keeping the property records in a courthouse, instead everyone who wants can have a copy of the records. But what about when a piece of land is sold again, right? So we all agree on our history but now a particular farm has just changed hands. How do we all, on each of our copies, remember, we each have our own copy, how do all of those copies update in the same way at the same time? Because if they're not updating in the same way at the same time, you can have room for cheating. So that's called consensus. Consensus is the way that you update multiple copies in the same way at the same time. And this problem of consensus is such a difficult problem in computer science that the first time it was solved was by Satoshi Nakamoto, which allowed him to create Bitcoin. And right now I'm sharing with you cryptography is used to update the network in the same way at the same time across the nodes. Now, I'm sharing with you cryptography as a black box for two reasons. One, you don't necessarily have to understand the underlying mechanism for how the network updates in the same way at the same time across nodes to take advantage of this sort of a system, but also because this technology is evolving extremely rapidly. And so how many of you have heard about Bitcoin being slow and Bitcoin using a lot of energy? It's because Bitcoin uses an old kind of cryptography to update its network in the same way at the same time, which makes sense because Bitcoin is the first blockchain. So why would it have the most advanced technology? And a little later in this presentation, we're going to go into some of the new ways of updating the network at the same way and the same time across nodes. But what's important to remember now is that if you've got blockchain, you've got a distributed system, a distributed database, where all the different copies update in the same way at the same time. And when you have your cryptography measure in place to update the network in the same way at the same time, each node, each copy of the transactions will add a new block of transactions to the blockchain. That's why it's called a blockchain. And the blocks, they're cryptographically connected. And so what that means is they're very sensitive to changes. So let's say I want to go ahead and change a comma to a period, or change a capital letter to a lowercase letter, even changes that small. I can only make that change if I want to go ahead and make a change like that no one can see. So it's one thing if I update the network with a new block, but if I want to go ahead and update the network as it's come to pass, if I want to update the history of the transactions, let's say I want to go ahead and update that first block of Bitcoin, how would I do it? You would have to update the block on over 50% of the nodes at the same time and in the same way, or the network will be able to detect that you tried to make that change and when you tried to make it and who you are. But you have to do it not only on over 50% of the nodes. You have to make the change on every single block in the whole history of the blockchain because the blocks are cryptographically connected. So think about what's harder if you want to go ahead and make a change on one Excel spreadsheet, no matter how well protected it is, or if you have to make that change on over 50% of a widely used network, on over 50% of the copies, same time, same way, and then on all of the nodes in the whole history of the blockchain on every single copy. That's very difficult to do. That's why blockchain technology is so secure. That's why. I'm going to share with you two different kinds of blockchains. So one is a permissionless blockchain. All parties can view all the data. So with Bitcoin, for example, it's a permissionless blockchain. And you can see the whole history of the Bitcoin blockchain. You can see every address. You can see how many tokens are held in each wallet. And you can see the history of all the transactions. And so we know which wallet belonged to Satoshi Nakamoto, whoever they are. We can see if any tokens ever actually move from Satoshi Nakamoto's wallet. And we can see, we know which addresses belong to the Winklevoss twins, etc. You can go ahead and find out a tremendous amount of information about the Bitcoin blockchain. So another myth about Bitcoin is that it's anonymous. It's very far from anonymous because of how much information can be gleaned from the network itself. But you might not want to have a secure database where everyone can see everything. And that's where you think about a permission blockchain. With a permission blockchain, you can actually choose who sees which data. And so if you're thinking about using a blockchain for secure records that you don't want everyone to see all the time, whether that's medical records or even certain kinds of government records, but you still want to take advantage of the advance of blockchain technology, you can use a permissioned blockchain. And with a permission blockchain, you can give the different users of your network various permissions, and depending on their level of access, that's the level upon which they can unlock the underlying data. So now that we know a little bit about what blockchain is, I want to step back and say, hey, when and why would we use a blockchain instead of an ordinary database? And the thing to remember about blockchain is it's decentralized sharing and storing of information. So there's two reasons why you're going to think, hey, this is a great time to use a blockchain database instead of a regular database. So first, with a blockchain database, you can't erase history. And when it comes to corruption, when it comes to some of the darker elements of our society, being able to make changes and get away with them, being able to erase history, being able to change history is key. There's a saying that the victors are the ones who get to write history, right? But with blockchain, every change in the database is time-stamped. It's coded to a key, and it can't be erased. And then the other factor that you want to consider if you want to think about using blockchain technology is whether you want cooperation between parties that otherwise might not trust each other. So when you're thinking about international cooperation, cooperation between companies, where you really need to trust what the other party is saying or telling you, but you can't necessarily verify that, that's when you want to think about using blockchain. So this is a picture of one of the most famous decentralized truces to break out in history. During World War I, on the Western Front, a spontaneous decentralized truce actually broke out among the troops. And so there were soldiers who were shooting at each other the day before, and they were shooting at each other the next day, but on Christmas, they were able to have a truce. And it was because they had this shared cultural understanding. They had such a shared understanding of what was important that was given to them by Christmas that they could have this truce. And so I invite you to think of blockchain technology a little bit like Christmas. The idea is that it can help you have a truce, it can help you have real understanding among groups and parties that you might otherwise really be fighting with, that might be real enemies. But one thing to remember, and this is key, so blockchain technology is powerful, it has tremendous potential, but it's not a silver bullet, and it's not a panacea. And what's its problem? Well, it's garbage in, garbage out. And so it doesn't matter how secure our database is. It can be an incredibly secure database, but if it's encoding false information, well, then we've just got a secure storage of false information. And so we need to be really thoughtful about who's writing to the database. What are our steps for updating the database when human error occurs, et cetera? And so that's a key thing to ask. I'm going to be sharing with you some examples of how blockchain technology is being used today, but you definitely want to keep this in your back of the mind. Garbage in, garbage out. How are we securing for human error and for who gets to write to the database? So one final piece of the technology before we can dive into some examples of how blockchain is being used today. So smart contract. I have some good news for you. I think that every single one of you has likely used a smart contract, whether or not you know it. So smart contract, also good news for the lawyers in the room, because you're not actually going to be put out of business by smart contracts. A smart contract is a piece of executable code that takes place without additional human intervention. And so if you've ever done automatic bill payment or signed up for a renewable subscription of Amazon or some other service, you've used a smart contract. But what's powerful is when you take smart contracts and you combine them with these secure databases, you actually open up a whole new possibility of interactions. So Gainforest is a project that's working on using blockchain technology and smart contracts to save the Amazon rainforest. What's it doing? With Gainforest, you can actually pay local indigenous communities in the Amazon for protecting their trees. And they use satellite imagery of the Amazon to go ahead and see, are those trees still there? And when you're donating, you donate a certain amount of money, and a chunk of that money is unlocked after 30 days, 60 days, 90 days, 180 days. You get to decide. And you say, hey, I want to protect these trees. If those trees are still there in X time, some portion of the money will automatically go to that community. And so it changes what's possible for donation. And it means that we can have these relatively complex contracts taking place without additional legal work and without needing to go ahead and send people, individual humans, to go explore the village and see if the trees are still there. We can take advantage of the satellite imagery. And so with blockchain technology, when you combine it with smart contracts, our money becomes programmable. And for another example of that, IBM is working with a trucking company called AOS. And for those of you who've dealt with trucking contracts with shipping, there's often rewards or bonuses that will be built in if the trucking shipment actually arrives on time or if it arrives early. There's a tremendous amount of time and money and legal time all spent on those contracts and on enforcing those contracts. But what AOS and IBM are doing is they're setting up the trucking contracts with smart contracts, where what happens is there's a GPS built into the truck, and when the truck arrives according to the GPS at its destined location, if it's on time, the reward will automatically be paid to the trucking company. And so it's not perfect. Again, you've got to think about, well, how is that GPS going to be cheated? But it opens up a whole new way of doing business. Cheaper, faster, and with less legal time. So this is a pretty cool way that blockchain technology is being used today. IBM and Maersk did a pilot last July that was so successful that by the end of last year, they put 10 million of Maersk's 70 million shipping containers, the administrative and documentation elements, onto a blockchain-based system. And then in January, Maersk and IBM launched a new joint venture called TradeLens. And TradeLens is an international platform for international shipping where you can go ahead and put your documentation elements of your international shipping onto a blockchain-based system. And this is powerful because until now with international shipping, we've had to have our documentation on paper. And paper's fallible, right? The pilot that was used here was actually taking avocados from Mombasa in Kenya and shipping them to Rotterdam in the Netherlands. And to get all of the documentation done in the right way, you actually had to have stamps and forms filed, and you had people by motorcycle in Kenya taking the forms from official to official. And Maersk is a company that was holding the assets but operating in the red. And small regional shipping companies were making 15 to 20% margins. And the people at Maersk are really smart. They have a lot of money to throw at the problem. They've spent over $500,000 on the system, the blockchain-based system. But there's a reason that it's only with blockchain that they've been able to actually start to digitalize the documents connected to international shipping. And it's because of permanence. So if you're involved in international shipping and an official along the way has said that a case is filled with avocados, but it's really white powder, you have a problem. But if you've kept your records online, the ordinary internet, remember our 404 error of the file not found, it's relatively easy for hackers to go in and change the record. And so with paper, even though it's not perfect, and you can hack paper, it's much harder to hack than the internet. And so we've been keeping many of our systems from being digitized. But now with blockchain, you can have a permanent, secure digital record. It's not perfect, garbage in, garbage out, but it means that we can put things online that until now we've never been able to put online. It's an incredibly sad and true problem that up to 1 in 10 medicines in the developing world, including here in Peru, are fake. And this is a problem all over the world. It's even a problem in the US and other developed countries. There's a huge problem of fake medicine. And one of the incredible benefits of the internet is the ability to connect and share information. It's also made it much easier to commit crimes and to commit fraud. And so fake medicine is an enormous problem. It's very difficult sometimes, even for a pharmacist, to know if they have the real article or if they have a fake. And if you're sick or your loved one is sick and you go into the pharmacy and you buy medicine and it doesn't have the active ingredient, that's an enormous problem. And there's now a consortium of pharmaceutical companies, including Genentech and Pfizer, and also pharmaceutical distributors, including AbbVie, that have come together to create a new blockchain-based network called MetaLedger in order to start tracking pharmaceuticals, because this is a problem for everybody. It's also a problem for, it's really a problem for pharmaceutical companies themselves, because it's really tricky for pharmaceutical companies to keep their margins if they're being undercut by fakes. And there's new compliance requirements in the US around actually tracking your pharmaceuticals. And it's very hard for the pharmaceutical companies to figure out how to comply with that new regime. And so blockchain technology poses this potential opportunity for compliance. So I've talked a bit about some of the ways that blockchain technology is being used today. I think especially here in Peru, where you have the opportunity to leapfrog, where you have systems that need change and you could potentially apply these new technologies. Part of why that opportunity is so great is because blockchain technology, the distributed web, this new way of engaging, these new sets of applications, they are something that even the tech giants in Silicon Valley don't fully understand and are not fully sure of what they're going to do. And so Mark Andreessen is a very famous venture capitalist in Silicon Valley, and he has famously said that software is eating the world. And so what that means is that if you're not a software company, you should go become a software company, because otherwise you're going to get disrupted. If you have margins, someone else is going to be able to figure out what you do better and faster than you can, unless you start operating with software as well. But now, with the decentralized web, with blockchain, there's the potential for software to eat software. The idea is, look, for example, Amazon Web Services, their margin is an opportunity for a new kind of decentralized file sharing company to come in and disrupt Amazon. Or Airbnb. Airbnb's margin is an opportunity for a decentralized Airbnb to come in and disrupt Airbnb. And Sergey Brin, who's one of the founders of Google, has actually said that he's worried that Google is behind on blockchain technology. Facebook has opened up a blockchain technology payments research group, but this is a key area of focus for these technology giants of Web 2.0, because there's tremendous opportunity here. And the other thing to remember is that in 1999, no one had any idea what Airbnb could be. People would have thought you were crazy to say that people would rent out rooms in their house to strangers via the internet. Or Uber. People would have thought you were crazy to say that you'd get picked up by a stranger in their car and they would take you to a destination. But what we found is that over the course of the development of the internet, from the dot-com crash in 1999 all the way up through today, we've constantly been surprised by the applications that have been developed. And so the applications of the future that matter, I'd argue, will be decentralized. And those decentralized applications of the future that matter, we don't always understand exactly what they're going to be, but we know there's tremendous opportunity, and they can come from anywhere, from any country. So if we go back to the presentation on how blockchain works, I want to share with you some future of the technology, where it's going, what's happening to it. But you've got to remember that black box of cryptography. So I said, look, the network is going to update the nodes, the copies, in the same way at the same time using cryptography. But the key question is, what is the consensus mechanism? How is the network going to be updating in the same way and the same time across nodes? So Bitcoin uses the first, oldest, and I would argue outdated method for updating the network, called proof of work. And so what Bitcoin miners are doing is they're spending tremendous amounts of energy figuring out a problem. What's the problem? Well, in front of every block on the Bitcoin blockchain, remember, you saw the first block, there's a number of zeros, a random number of zeros. So 1, 2, 3, 900,000, 89. Every single block on the Bitcoin blockchain has a number of zeros in front of it. And the first miner, the first person or entity that's applying energy to the network to solve the problem of how many zeros are in front of the network, that's the miner that gets to push a new block of transactions onto the blockchain. And if you're a miner and you solve the problem, let's say you figure out it's 873 zeros, if you want to go ahead and cheat with the block before you put it out, someone else is going to do it first because the miners are competing with each other. But what Bitcoin does is it only lets the network update every 10 minutes. And so when Bitcoin first came out, the network was updated with very small computers. You could mine Bitcoin with a laptop or a small desktop computer. But then as more people started using Bitcoin and the Bitcoin network became more valuable, more people started mining, and somebody figured out that they could bring to bear a more powerful computer. And then somebody else figured out that they could bring to bear an even more powerful computer. And now you have these enormous server farms mining Bitcoin, and all of that energy is being wasted because it's just going to calculating how many zeros are there in front of the block. And so cryptographers have been working on a better way. And one example of a better way of updating the network is something called proof of stake. And with proof of stake, what happens is if you hold tokens in the network, you can stake your tokens and run programs in the network to actually verify and update the network. So Tezos is an example of a blockchain. It's public, it's live today, and it's operating using proof of stake. And with proof of stake, the incentive against cheating is that if you go ahead and validate a false block, you'll lose your stake. So you have skin in the game, and if the network is decentralized, it's very difficult to collude and to get a large enough portion of the bakers, the stakers, they're called bakers in Tezos, of the bakers to go ahead and cheat. And so the network is kept secure, but in a way that is much, much, much less energy intensive and actually faster than Bitcoin. So remember, we've got proof of work, we have proof of stake, and we actually have even more advanced technologies than even what we might call blockchain itself. So with blockchain technology, remember I shared with you, we're updating the network in the same way at the same time across the nodes. And every node is carrying a whole copy of all of the transactions that have ever happened. Now that works for a while, but if we start having a popular network that lasts for a long time, how can every single copy have the memory to keep all of those transactions? I mean, imagine if we had the Visa network going all the way back from the beginning, and every single copy of the nodes, there's millions of copies of the Bitcoin blockchain, millions of nodes. If there were millions of nodes and they all got updated, it would require exponentially more energy over time. And so cryptographers are coming up with new technology, like sharding. And what sharding is doing is it's a provable way of updating the network as a whole in a way that keeps it secure and that keeps the permanence, that keeps the ability to cooperate among parties that otherwise don't trust each other, but you're not actually updating every single copy with the whole history of the transactions. You're updating the copies in organic, provable ways where different nodes will have different aspects of the blockchain as a whole, and you can reconstruct the whole blockchain from sets of nodes. And so that the technology is advancing so rapidly that we can call that blockchain or not. Some people are saying that sharding is not blockchain. Regardless, the key is to focus on the decentralized nature of the information, the permanence, the fact that you can coordinate with parties where you otherwise wouldn't trust each other. And so what I think that's really incredible is that this technology means that we have a new way of doing old things. We have a new way of sharing and storing our information. We have a new way of making payments. We have new ways of developing land registries. And in places where our systems work pretty well, we might see later adoption than in places where we really need change. Maybe in places where we really need to fight corruption. And so I think there's this tremendous opportunity for this technology to support Peru and to help Peru to leapfrog. And a couple points to close. So blockchain technology, why are we talking about it now? I think there's two reasons. So one reason is this technology is pretty brand new. It's cool. We've got a very volatile cryptocurrency market that's exciting, although a lot less fun to talk about right now than a year ago. But also, researchers think that the business value that can be generated from blockchain technology is over $3 trillion by 2030. And we're talking about tens of billions now. And so that's tremendous, tremendous, tremendous opportunity. And I think that's why we're talking about this technology right now today. And so finally, I'm going to leave you with a challenge, which is, how will you use blockchain? And if you want help here in Lima, the Blockchain Challenge is a very cool project working throughout Central America, but with a team here involved in some very cool initiatives. And so I recommend that you check them out, the Blockchain Challenge, and look at more about what they're doing just here in Peru. And with that, thank you for taking the time to listen to me today. It's an honor and pleasure to be here, so thank you.